found this question about the higher order partial derivative. Do you know how to do this?
Oh, this question is actually easy. I show you how to do it.
For my part is to find the first and second partial derivative of the f is equal to xy over x equal to y equal to 2. First of all, we take the constant dy from the equation and we apply the equation rule as you can see here. Simplify it. Then next, simplify the equation. You can see here. Then it becomes y squared minus x squared over x squared plus y squared equals 2 plus y. Then second, find the del over del y. We take the constant x out if we want to differentiate with respect to y, as you can see here. And then we apply equation rule again. Comes 2y. You can see here 2y, and simplify it. Comes 1 times x squared plus y squared minus 2y squared times x over x squared plus y squared 2. Then we simplify the numerator as you can see here, and so that it will become x squared plus y squared minus 2y squared, and finally it will become x over x squared minus y squared close bracket over x squared plus y squared times 2 x squared plus y squared to the power of 2 for the del over del y. Lastly, we find the partial derivative for del 2 over del y del x. We differentiate the del over del y with respect to x, which is del over del x. First of all, we apply the product rule to the function, as you can see here. Then we do it one by one, which is we do it the numerator first, as you can see here, so that it will become, for the first part, 3x squared minus y squared. And then the next is we differentiate the top right, so that it will become 4x x squared plus y squared. Next, we put it back to the long question. It will become 3x squared minus y squared, x squared plus y squared equals 2 minus 4x x squared plus y squared, x times 2 x squared minus y squared. We simplify it one by one. As you can see here, factor out the common term, apply the exponent rule between them. Next, you can see here, we add and minus between the common terms between them. Thus, the end result will become 2x squared y squared plus 3x power 4 minus y power 4 minus 4x squared x squared minus y squared. Next, we need to expand it to simplify it more. And then you can see here, expand the negative 4x squared times with x squared minus y squared. And then, so that it will become negative 4x squared plus 4x squared y squared. Last but not least, we simplify the whole equation to become more compact. We group the like terms and add the similar elements, and we factorize it so that it will become x squared plus y squared bracket negative 4x power 4 plus x squared y squared minus y power 4. Then last but not least, we simplify the denominator to become x squared plus y squared to the power of 4. Then cancel out the common factor between them. Then we rearrange them so that the final product will look like this, which is negative x power 4 plus 6x squared y squared minus y power 4 over x squared plus y squared, close bracket, of t.
So that's how to solve that question, the higher order partial derivative. So Firdaus, I have a question on rate of change of a certain distance. Can you show me how to do it?
Okay, for this question, it's not very difficult. So this is how you do it. Question 2. A car is travelling north toward an intersection at the rate of 60 miles per hour, while a truck is travelling east away from the intersection at the rate of 50 miles per hour. Find the rate of change of the distance between the car and truck when the car is 3 miles south of the intersection and the truck is 4 miles east of the intersection. By extracting all the information given, we have x, distance travelled by the truck, y, distance travelled by the car, dx dt, rate of change of truck, dy dt, rate of change of car. But the question asks us to find the rate of change of the distance between the car and truck, which is dz over dt. By visualizing the question, let x, distance travelled by the truck, is 4 miles east of the intersection, and y, distance travelled by the car, is 3 miles south of the intersection. But for z, distance between car and truck, we have to use Pythagorean theorem equation, which is x squared plus y squared equal to z squared. So by using the equation, we have the distance between car and truck equals to 5 miles. Next, we have to differentiate with respect to time. So for dx dt, rate of change of truck is 50 miles per hour because it is travelling away from the intersection. For dy dt, rate of change of car is negative 60 miles per hour because it is travelling toward the intersection. By following the equation, we replace x equal to 4 miles, dx dt equals to 50 miles per hour, y equal to 3 miles, dy dt equals to negative 60 miles per hour, and z equal to 5 miles. Next, we move 5 miles to the left so we can divide. So, for the final answer for dz dt equals to 4 miles per hour. Hence, the distance between the car and the truck is increasing at the rate of 4 miles per hour at the time.
Hello Nash, I want to ask you about the question, the approximate change in the current, and can you solve it?
Okay, let me see. Oh, this is a question about the approximate change in the current. Oh, this is easy question. Let me teach you how to do it. I will do the calculation. Then from the question, we will get the information is V equal to 120 volt and the resistance is 200 ohms. And if we from the question we will get the dIdV is negative 2 because it is decreasing, and the IDR is positive 0.4 ohms because of it increasing. And from the question we can derive the formula to VR minus 1. And the calculation, if we differentiate the V, we will get 1 over R, and when we differentiate the R, we will get negative V over R to the power of 2. And the approximate current is di over dV, V plus di over dR and R. And then we substitute the di dV, we will get 1 over R V plus negative V to the over R to the power of 2 and R. Then we substitute the information negative 2 from the dIdV and 0.4 ohm from the IDR. Then from the information that we get from the question,
we substitute the V and R. We substitute the R at the bottom and it will be negative 2 over 200 minus 120. We substitute the V and we substitute the R. We will get 200 to the power of 2. And then we do the basic calculation and the approximate current, we will get negative 0.0122 amps. So the approximate change of the current is decreased to negative 0.0122 amps. That's all.
Haziq, I just found a question about finding the minimum that relates to our tutorial 10. Can you explain to me how to solve this question?
The packaging section in a company has been asked to design a rectangular box with no top and a partition down the middle. The box must have a volume of 1296 cubic centimeter. Find the dimension that will minimize the amount of material used to construct the box. So this is a function of xy m equal to xy plus 2hx plus 3hy. So we let h into the function of m, xy plus 2 in a bracket 1296 over xy, close the bracket, multiply with x, plus 3 in bracket 1296 over xy, close bracket, multiply with y, and equal to xy plus 2592 over y plus 3888 over x. Okay, this is the del square f over del x square. So we let the x and y into the equation. 7776 over 18 power of 3. So we calculate, then we get a 103 over 81. Then the second one is del 2f over del x del y. We only get one value because we don't have I don't get any x and y in the equation, so the answer is only 1. So this is the last one is del square f over del y square. The x and y put into the equation. The answer is 103 over 36. So now we need to do the second derivative test to locate the minimum and maximum. So del square f over del x square multiply with del square f over del y square minus with del square f over del x del y power of 2 equal to 103 over 81 multiply with 103 over 36 minus with 1 power 2 equal the answer is 7683 over 2916 is greater than 0. Therefore m x is 18, y is 12 is a minimum and there is no maximum.
Alright, Nas, this is how you do it. Do you understand? Alright, I understand.